The second type of travel graph is speed time graph. So as the name suggests, if you got the speed time graph, I'm plotting the time against, I'm plotting the speed against time. Okay, so I'm plotting the speed against time. And then, so usually if you start from rest, you are starting from zero. So, and again, right, you will have different feature of the gradient. So in this case, the gradient will represent acceleration. So what is the idea of acceleration? Acceleration is how fast you increase your speed. So it is like how fast you increase speed. Okay, so maybe it's like if I'm in a rush, I need to rush to somewhere from 0 to 80 kilometer. I will just accelerate very fast. So from 0 to 80, I might just take like 2 minutes or like maybe even 1 minute. Okay, but if I'm not in a rush, maybe I can increase 0 to 80 like over 5 minutes. That means I slowly increase my speed. I don't need to increase my speed so fast. So acceleration is like how fast I'm going to increase my speed. So imagine if you're going to go someplace in a rush, you are late for school. So your mom or dad got to drive very fast. So you will tend to accelerate very fast. Okay, so that the gradient is represent how fast you increase the speed. So because of this, right, there will be a difference between positive gradient and negative gradient. So when the gradient is positive, right, that means you're actually increasing the speed. But at the point where I'm going to stop, I got to decrease my speed slowly. So if there is a negative gradient, right, it's actually called deceleration. That means it's how fast you slow down. So you can imagine slowing down like, for example, if let's say if your parents is driving and if your parents got to stop abruptly, then the slowdown is very abrupt. That means the deceleration is very steep. Okay, so that means you like maybe you find yourself suddenly you jerk forward because your parents suddenly do a sudden stop. That means the slowdown is very steep and it's very fast. Okay, so if your parents slow down slowly, then of course it's if you feel more gradual. So deceleration is how fast you slow down. Okay, how fast you slow down. And if you slow down very quickly, it will be quite abrupt. Okay, so there will be a difference between positive gradient and negative gradient. Okay, and again, right, there is also a horizontal line. So unlike the distant time graph, a horizontal line on a distant time actually means constant speed. Okay, it's still moving. It's just that they are not increasing the speed, they are maintaining. So I think I can summarize all this on a diagram. Okay, I'm going to summarize this idea on the diagram. Okay, so the easiest way to explain this diagram will be something like, so for example, I'm leaving home, I'm going somewhere by expressway. So when I leave home, okay, my car is starting from where? So of course my speed is 0. Okay, so I increase my speed slowly. Okay, so I do a positive gradient. So I try to increase my speed slowly. Okay, maybe I take around like 15 minutes. Okay, really slowly, and I increase to 90 kilometer per hour. So when I increase to 90 kilometer per hour, when I hit the expressway, okay, the speed limit is 90. Okay, so it only makes sense that I maintain my speed. Okay, so I got to travel, I maintain my speed. Okay, I shouldn't exceed the speed limit. So this horizontal line means I maintain the speed. I maintain my speed. So because I'm maintaining my speed, right, I'm not increasing any speed. So actually the gradient is 0. Means, right, I got no acceleration. I'm not going to increase my speed. So at this horizontal line, right, my gradient is 0. That means I have no acceleration at all. Then of course, okay, so if let's say after I'm cruising at the expressway, after a while I got to slow down. So there's a traffic jam. So I got to slow down. So my slowing down will look like this. So this part is the slowdown. So then I come to a total speed 0 again because I can't move in a traffic jam. Okay, so first of all, I increase my speed. Then after that, when I hit the expressway, I maintain same speed. Then when I see there's a traffic jam in front, I got to stop gradually until I got no movement. So like we mentioned just now, there's a feature. The gradient actually tells you the acceleration. So there's also another feature. The other feature is the area under graph. The area under graph will tell you the distance traveled. So for example, if I like to find out how long on the expressway I maintain my speed, I will calculate this rectangle. So if I calculate the area of this rectangle, that will be the distance I actually maintain my speed on the expressway. So that is another feature that is on the distance graph. Speed graph, sorry. For speed graph, we've got two special feature. For distance graph, there's only one special feature. So you should, if you are worried that you forget, I think the moment you see there's a speed graph, you should write down the two feature at the side. If you see that there is a distance graph, then you should write down the feature at the side. Okay, and then sometimes, right, on a speed graph, okay, you may be asked to find a certain speed. So for example, I would like to find the speed, let's say 10 minutes. 10 minutes after I start driving. What was the speed? So you can be asked on this. So sometimes we will use similar triangle to help us. Okay, or sometimes we can use gradient, or we can use gradient method. Okay, which I can show later. But sometimes we can read off directly. If let's say this speed graph is on a graph paper, so you can read off directly. But if this speed graph is not on the graph paper, you actually got to calculate. So these are the two methods. We can use similar triangle or we can use a gradient method. Okay, so later on there will be an example to show this part. And there's also an idea about two objects overtaking each other. So when two objects overtake each other, or sometimes when they meet, or when they collide with each other, there is a concept about distance traveled being the same, which also means, right, area under graph is the same. This part, I think it's easier if there's an example to show. So at the moment, right, you don't be too concerned about this first. At the moment, you should be concerned about the feature. The feature will be the gradient feature and the area under graph feature. Okay, so I'm going to use an example to show the two feature. So in example 1, they will be showing two feature. So example 1 is the distance time. sorry, speed time. So if I would like to find the distance traveled, typo error, double L. So distance traveled in the first 10 seconds, that means, right, it is the area that I'm interested in. So the area that is here. So this is a trapezium. You can do it as a triangle first. So you can take it as triangle plus rectangle. So for part A, if I would like the distance in the first 10 seconds, okay, in your head, right, you should be thinking about half time base on height. So that will give you the distance. And take note of the units. Okay, the next one, we are finding the acceleration. So that is the other feature. The acceleration will be the gradient. So from the 10 to the 15 seconds. So I'm interested in the whole gradient here. So you can use vertical over horizontal, or you can use coordinate. So if let's say I'm using vertical over horizontal, so look at the vertical. The vertical is the change in the speed. So the change in speed from 5 meters per second, it increases to 15 meters per second. So there is an increase of 10 meters per second. And there is an increase over 5 seconds. So that means, right, okay, it's 2 meters per second square. So that is the acceleration. So some of you may be a bit confused why there's a square. So it's something like m divided by s divided by s. So that's how we get s squared. So that's the units of acceleration. Or some people can express it in indices in this way. Okay, so it's not a must. Usually we will just write like this. So that means every second. So what is the interpretation of acceleration? That means every 1 second, speed increase by 2 meters per second. So that is the idea of acceleration. Okay, so part A and part B already illustrate the feature of gradient and area under graph. So part C, again, is a feature of area, but it's the opposite idea. So they tell us that the total distance is 100, and then we would like to find the time. So that means they gave us a full area. They gave us a full area of 100. So just now we already know that this is 42.5. Okay, I can calculate this trapezium. So let me calculate that trapezium first. So half times height, sum of the parallel length. So that will be 50. So this part will be 50 meters. So they are giving us a full total distance. So the total distance cover until here. So this whole area is 100. So that left me a triangle. So I can actually form an equation. So I can form an equation for 2.5 meter plus 50 meter plus the triangle, half some base, some height. The base will be t minus 15, and that will be equal to 100. So you can do that and solve it like an equation, but your equation is formulated based on area. So t is 16. So the time that the particle comes to rest will be 16. That means 16 seconds. The whole journey takes 16 seconds. So that will illustrate the main feature, the distance and the acceleration feature of a speed time. So this is a key thing first before there are more complex questions.